So this is video 1.5C in college algebra, and this is called functions defined piecewise. Now piecewise can look a little bit scary, but it's really not too terrible. So let's give myself a function. This is example 5. 1/3 x plus 3 and negative x, and this says x is less than 3, and this is x is greater than or equal to 3. Alright, so what a piecewise function does is it says depending on what numbers you decide you're going to put in for x will determine which of these two equations you're going to use. Okay, let's just throw out a number for x. Let's put out throw out the number 4. If we're going to use 4 as a number, we're going to use this equation, because this equation says we're going to use this equation when the number we throw out there is bigger than or equal to 3. Then we're going to use this. If we used a number like -1, it says we're going to use this equation because this equation is usable only when x is, the number that we throw out there, is less than 3. Okay, so we've got two different graphs basically. So we've got a graph when x is less than 3, because we're going to use that equation. So let's go ahead and do that. G of x instead of y. So I'm going to throw out some numbers that are less than 3. -3 is less than 3, and when we plug it in there we get a 2. 0 is less than 3. When we plug it in we get a 3. 2 is less than 3, and when we plug it in we get 3 2/3. Oh, that looks terrible. Try it again. 3 2/3. Alright, now let's look at some where x is greater than or equal to 3. Alright, so let's put 3 in there because that's equal to 3. That gives me -3. I'll put 4 in there. That gives me a -4. Put 6 in there. That gives me -6. Alright, and if they want you to graph it, pretty simple to graph. Got your graph here. We're going to graph this one. -3, 2. 0, 3. And 2, 3 2/3. Okay? 4 when x is less than 3. So what does that do? It gives me a line right here. But this x value, notice, what happens here? This line here cannot go forever because I said that x cannot be bigger than 3. This thing has to stop where x becomes 3. So this part right here of the graph can't exist because x is bigger than 3. I mean, if we got to this point, our x is 4 and can't do that. So what we do is at 3 we draw an open circle to say that it can include all numbers up to 3, but the open circle means that it does not include 3. Now let's graph this one. We'll do this in purple. 3 -3, 4 -4, 6 -6. Okay, so we've got this line right here, right? Now let's look at what it says here. It says that x has to be bigger than or equal to 3. Bigger than or equal to 3. So none of these numbers for x work because they're smaller than 3. So that means these y values don't work. So that means that this goes away, but we have a closed circle at 3 because can x be 3? Yes, x is greater than or equal to 3. So a closed circle means that it can be 3. The open circle means it cannot be 3. See, it says it cannot be. So we have a graph that looks like that. For open circle, down, closed circle, down. And that is what the graph would end up looking like. I mean, this scribbly stuff here is gone, and this scribbly stuff here is gone, and that's what we'd end up having for the graph. That's what a piecewise function is. It just means you're going to take a piece of the function, depending on what your x value is, and solve it. So let's go ahead and get rid of this. So this is example 6. So we've got three different things that we're looking at as far as the graphs are concerned. So what we're going to do is we're going to look at my first one. And what it says is that whenever x is a number less than or equal to 0, my y value is going to be 4. So it doesn't matter what number I plug in here. I can plug in a -5, a -3, a -2, and my y value will always be 4. That's what it says. It's going to be 4. There's no option to change that. Can my x value be 3? No, it cannot, because this says any number that is less than or equal to 0. Okay, so let's go ahead and put a graph up here. And it says whenever x is less than 0, my y value is going to be 1, 2, 3, 4. So it can be 0, so close circle, and it's going to go this way. It's going to stay 4. My distance from here to here is going to be 4 all the time. All right, let's look at the next one. I've got x and I've got f of x. So let's say my x in this case can only be a number between 0 and 2. It can be 2, but it cannot be 0. So let's put in a 1/2, because it can be 1/2, because that's bigger than 0 and less than 2. It can be 1, and it can be 2. So let's see what I get. 3 and 3/4. And I put 1 in there. 4 minus 1 squared is 3. 4 minus 2 squared, that's going to be 0. So let's go ahead and graph that. 1, 3, 2, 0, and then 1/2, 3 and 3/4. So I get a graph that kind of goes like this. Okay. And notice I do not have an open circle here, because x can be equal to 0, so that closes it, even though x cannot be 0 for this next part here. But because one of them could be 0, then it's just a closed circle there, because one of them is closed, so it closes it for both of them. That makes sense. All right, so that's that one. All right, so x, f of x, and this last one, it has to be a number bigger than 2. So let's put 3 in there, let's put 5 in there, and we get 0 and 4. So we get 3, 0, and 5, 4. So we get another number like up there, and when we draw this, we get like that. All right, so how far down does this go? Well, what can x not be? X has to be greater than 2. Can it be 2? No. So when we get to 2, there's where my x is 2. X can be greater than 2, so it does not include this part of the graph, does it? Because my x is going to be less than 2 if I use that part of the graph, and it has to be greater than 2. So it starts here, open circle, because it cannot be 2, and it goes up that way. So this is what my graph looks like for example 6. Piecewise, you just look at each one of these and graph each piece on one graph, and then that gives you your answer. So this is example number 7, and we've got two different pieces here. We have one when x is not equal to -2. So x can be any number in the world, and we're going to use it as long as it's not -2. We can use this equation. Only when x is equal to -2 are we going to get this point. So this point's really easy. When x is -2, y is 1, 2, 3. Dot. That is the graph of that right there. Alright, so when x is any other number, then we've got to make our little table here. So when x is, let's say, 0. 0 squared minus 4 is -4 over 2. That gives me a -2. So when x is 0, y is -2. Okay, and we basically get this graph of a line that looks like that. The only problem is it says any number works for x. Any number along here works, any number in the negative works, except -2. We cannot use -2. So what do we do at -2? Come down here, and it can't be that. I mean, that can't be on the graph. So what we do is we make an open circle saying that every number this way we plug in for x, every number this way we can plug in for x, any number this way, any number this way, except that point -2. When we come over -2, we go down, we hit the line, we have to put an open circle there and say it does not include this number -2, because this says does not include -2 on this graph, which is this one. Now at x equals -2, we do have a point, but it's up here. Okay, up here all alone. So we have this graph here, that red, with the little white open circle, and a solid point here. The solid point represents this. The red point with the white circle represents that. And that is what example 7 looks like. Okay, so we're going to cut it short here on 1.5. We're going to skip the greatest integer function. I don't remember if we go into it again later in the book, but they just kind of real briefly don't really even give you much of an option to understand it in this section, but I think that you'll get more of an option to understand it later on in the book, so we'll just take our chance there, because right now they just kind of give you some real brief stuff that really doesn't make a whole lot of sense without a lot of practice. So we'll just not worry about that right now, and that'll be it for section 1.5.